So today we are talking about kinematic equations, and we're going to go over how to list them out, how to figure out how we're going to solve them, and the different variables you need to use. Now, to begin with, it is very important in physics, you greatly must know your different units for your variables. It is very important because as long as you know units, you'll know which variable to use, because that's what's going to be your clues, your context clues inside the word problems, because physics is always word problems. So let's start with acceleration. What is our symbol for acceleration?
I think it's A.
It is A. Acceleration, A. Our units for acceleration will always be meters per second squared. So anytime you see meters per second squared in your word problem, what letter are you going to plug in? A. Now, the second we're going to look at is initial velocity. Do you know what the unit is for initial velocity?
It has to have a V.
It does.
VS for start?
Initial.
Oh, so VI.
VI, good.
Oh,
VI is what we use for initial velocity. Now you can think of it as velocity initial. The units we always measure initial velocity in is meters per second. So
Is
anytime.
that square?
No, not square.
Okay, I just want to make sure.
So anytime you see meters per second, it's going to be a velocity. All right, so following that, the next one we have is VF. What do you think that stands for?
Velocity is funny.
No, your face is funny. All right, final velocity. That means the end. Final means the end of things, the end of world, the end of days. Final, the very end. So final velocity, VF. We're always going to measure in meters per second, just like initial velocity. Are we good so far?
I think so.
We're good? Okay. The next thing we have is time. What letter could possibly represent time?
Isn't it a big T?
No!
Oh, wait, big T is temperature, right?
Big T is temperature, so that means what stands for time?
The lowercase t.
Here we go.
Okay.
Got it.
I'm
Lowercase
sorry.
t, time, lowercase t. Use a big uppercase T. You're going to be measuring temperature, and that's not good. We don't want that right
And
now.
temperature doesn't typically have seconds. It's usually like degrees, right?
Exactly.
Okay.
So you can't say it's 32 seconds hot outside. That makes no sense. So we always measure temperature in seconds, just like she was just talking about. So seconds. We don't measure it in minutes. We don't measure it in hours. We measure it in seconds. So remember to convert if you're given something into hours. Finally, we've got distance and or displacement. What do you think we use for that?
Well, they both start with a D, so is it a big D?
It'd be a little d.
Why is it little? What's the big D?
Oh, good Lord. Either distance or displacement is always going to be a lowercase d.
Okay, I'll
Okay.
just draw the little D then.
Little d. Now, it's measured in meters. So if we're given something in kilometers, what do we need to do?
I need to convert it.
Yes, you have to convert it into meters. So if you look at your guided practice problems, you look at number 1, it says, I'm hurrying is approaching a stoplight moving with a velocity of 30 meters per second. The light turns yellow and Ima applies the brakes and skids to a stop. If Ima's acceleration is negative 8 meters per second squared, then determine the displacement of the car during the skidding process. Note that the direction of the velocity and the acceleration vectors are denoted by positive.
Okay everybody, so what I've done for you guys here is I've went ahead and I've pulled out all the information that's going to be inside of our guided practice onto the side of strategy 1 listed here. So we know that we have an initial velocity of 30 meters per second and a final velocity of 0 meters per second with a negative acceleration of 8 meters per second. And in the strategy that we have here, it's the D equals VF squared minus VI squared over 2A. So what we would do here is we want to go ahead and plug in our information. We don't know what D is, so we're going to go ahead and write D as our missing variable equals to VF squared, so that's going to be 30 squared, not 30 squared, 0 squared. So 0 squared minus our initial velocity, which is 30 squared, divided by 2 multiplied by our acceleration, which is going to be negative 8. Now we want to go ahead and add these things together, or add, divide, multiply, do our exponents and such like that. So 0 squared is still going to be 0 minus 30. So D is going to be negative 30 squared into the calculator. Plug that in. That becomes negative 900 over 2 times negative 8. Well, 2 times negative 8, put that into your calculator, and that will yield you a negative 16. So D is going to equal 900, negative 900 divided by negative 16. Well, the two negatives will cancel each other out, so you don't have to worry about that. And you are left with 56.25 meters. And that's going to be your distance. Now that's strategy 1. Strategy 2 is going to be much, much easier than having to go through all the conversions and such. Again, we like to use the guess method when we're working with this. And we want to already pull out our givens. Our givens are located right here. And our unknown is going to be D, right? So we're still trying to figure out D. D is still going to be our unknown variable. But let's go ahead and plug it into our original equation we had before we started converting all these things to find D. So if we go ahead and plug it in, where A equals VF squared minus VI squared divided by 2D. That's our original equation. So let's go ahead and plug in what we have into this equation. Well, we do have an A, so negative 8 is going to equal to VF of 0 squared, minus 30 squared. Let's go ahead and separate that. Divided by 2D, because again, we're still trying to find D, right? Well, we want to go ahead and multiply 2D on each side to get that out of the way. These will cancel out. So we're left with is 2D times negative 8, make that times a little bit bigger, equals to, well, we had 0 squared, that means nothing. Negative 30 squared, that was again 900 over nothing, because that already canceled out. 2D times negative 8 becomes negative 16D equals 900. Now we have this right here, these last little bits. Now we want to get D alone by itself. So in order to get this alone by itself, we do what's called inverse operations. Now you should have already watched a video on this, but if we forget what inverse operations is in order to get this number here on the other side, we need to do the opposite on what it's doing to the variable next to it. In this case, 16 is multiplying by D, so we need to divide each side by negative 16. And again, whoops, this was a negative because that there was negative. So negative 16D divided by negative 16 will just leave us with D, and that'll end up with the grand total when these two are done. D equals 56.25 meters. And that's again your answer. Alright guys, we're going to go ahead and work on this next question. It says, Ben Russian is waiting at a stoplight. When the light finally turns green, Ben accelerates from rest at a rate of 6.3 meters per second squared for a time of 10 seconds. Determine the displacement of Ben's car during this time period. Again, like I said, we use the guess method, so we want to pull out all the stuff that's given to us. Right off the bat, it says Ben Russian is waiting at a stoplight. That gives us his initial velocity, his VI. Because VI is going to be equal to 0. When the light finally turns green, Ben accelerated from rest at a rate of 6.3 meters per second squared. So that's acceleration. Let me go ahead and erase that. Let's make it a little more clear. Acceleration is equal to 6.3 meters per second squared for a time of 10 seconds. Well, let's go ahead and figure out what it's asking us. Determine Ben's displacement. So we're looking for his displacement, trying to find D. Well, now that we have our givens and we've figured our unknown, now we can locate which equation that we need to use. In this case, the equation is going to be D equals VI multiplied by the change in T plus 1/2 A change in T squared. So I'll write this out for you. D equals initial velocity multiplied by the change in T plus 1/2 multiplied by a multiplied by your change in t squared. Alright, so now we have the equation written. Now we can go ahead and substitute in our first little bit of information. In this case, that we don't know d, so again that's still going to be our unknown variable, equals vi, well that's 0, multiplied by your change in t. Well, our time is going to be times 10. In that case, 0 times 10 is going to be 0, so that cancels out, plus 1/2 at squared. Now, an easy, quick way to put half into a calculator is just to simply type decimal 5 or 0.5. 0.5 multiplied by our acceleration was 6.3. Multiplied by the change in time squared. So, in this case, we don't have a final time, we just have we have a final time, we don't have an initial time. So 10 squared. Now that that's out of there, we can go ahead and figure it out. D equals 0.5 times 6.3 multiplied by 10 squared will equal out to 315. And again, this is going to be distance or displacement, so that's going to be in meters. And that's going to be your answer for this one. Alright, and on to our final guided practice question. Michael was on his bicycle traveling at 20 meters per second, and he slows to a stop with an acceleration of -5 meters per second squared. How long did it take him to come to a stop? And now in this case, I've already pulled out your givens for you, and I've already found out what your unknown variable is. His initial velocity again was 20, and he slows to a stop. We know, guys, that when you go to a stop, our acceleration or our velocity becomes 0. And his with an acceleration of -5 meters per second, how long did it take for him to come to a stop? Now, with this, we can go ahead and determine which equation we're using. The equation that we're using is going to be acceleration equals to the change in velocity over time. Now, again, remember, guys, that change simply means final minus initial. So we're going to take your final velocity and subtract your initial velocity. So our final velocity was 0, and we're subtracting our initial velocity, and that's going to be 20. So our change in velocity is going to equal -20. So we're going to go ahead and substitute in what we know. Acceleration is equal to -5 equals -20 over t. Well, and I'm going to go ahead and multiply each side by t so we can get everything on an even playing field. Those two will cancel out. So we have -5t equals -20. Now we want to get t by itself, so we want to get this guy over here on the other side of the equation. And again, to do that, we do inverse operations. We do the opposite on what this number here is doing to this number, or to this variable. In this case, this one is multiplying these two, so we want to divide each side by this -5. Divide each side by this -5. These two will cancel out, and it'll move it over here. So now we have t equals -20 over -5. And we plug this into our calculator, it'll give us our answer, where t is equal to 4 seconds. And that's it. That's all you need to do.